Dr. Sarah Monroe peered through the frosty glass of the cryonic storage chamber, her breath creating small clouds in the frigid air. The chamber, filled with liquid nitrogen, housed the preserved bodies of individuals who had chosen to gamble on the future people who had died with the hope that advancements in science would one day bring them back to life. As the leading cryobiologist in charge of the Cryonics division of the Immortality Task Force, Dr. Monroe was at the forefront of this delicate and controversial field. Sarah's journey into cryobiology began during her medical training at Johns Hopkins University, where she witnessed firsthand the limitations of modern medicine. Her interest in life extension and preservation was sparked by a lecture on hypothermia's protective effects during heart surgery. This led her to pursue a PhD in cryobiology, focusing on the preservation of biological tissues at ultra-low temperatures. Her research quickly made her a prominent figure in the field. Dr. Monroe developed advanced cryopreservation techniques that minimized ice formation, which was crucial for maintaining cellular integrity during the freezing and thawing processes. Her innovations promised to push the boundaries of what was possible with cryonics, moving the field closer to its ultimate goal, preserving entire human bodies for future revival. When Augustus Musa extended an invitation to join the Immortality Task Force, Dr. Monroe saw an unparalleled opportunity to overcome the limitations of current cryonic technology. The extensive resources and interdisciplinary collaboration provided by the task force offered a unique chance to refine her techniques and to address the scientific and ethical challenges of cryonics. Dr. Monroe's work focused on several critical areas. One major project involved improving the vitrification process, a method of preserving biological tissues by cooling them to a glass-like state without forming damaging ice crystals. By perfecting vitrification, her team aimed to preserve organs and bodies with minimal structural damage, increasing the chances of successful revival in the future. Another key area of research was the development of advanced thawing methods. Safely bringing a cryonically preserved body back to life required precise control of the rewarming process to avoid thermal stress and ice recrystallization. Dr. Monroe's team was experimenting with nanoparticle heating and other innovative techniques to ensure that thawed tissues remained viable. Despite these advancements, Dr. Monroe was acutely aware of the ethical and practical challenges associated with cryonics. The primary ethical dilemma was the uncertainty surrounding the future ability to revive cryonically preserved individuals. While current technology allowed for preservation, there were no guarantees that future science would be able to repair the cellular and molecular damage caused by the freezing process or cure the ailments that led to their initial deaths. Dr. Monroe often found herself grappling with these uncertainties. She held deep respect for the individuals who chose cryonics, viewing their decision as a profound expression of hope and trust in scientific progress. However, she also recognized the emotional and financial costs involved and felt a responsibility to manage expectations realistically. One evening, as she reviewed the latest data from her lab, Dr. Monroe received a message from Augustus Musa requesting an update on her progress and thoughts on the ethical dimensions of her work. Sitting at her desk, she began to compose her response. "Augustus," she wrote, "our advancements in cryopreservation are promising. We have made significant progress in improving the vitrification process and developing safe thawing methods. These innovations increase the likelihood that cryonically preserved bodies can be successfully revived in the future." She paused, reflecting on the broader implications of her work. However, we must confront the ethical challenges inherent in cryonics. The uncertainty about future revival capabilities means we are asking individuals to place immense trust in the unknown. It is imperative that we communicate these uncertainties transparently and strive to develop a robust ethical framework to guide our practices. As she sent the message, Dr. Monroe felt a mixture of both determination and responsibility. The quest to perfect cryonics was a noble endeavor, but it required a careful balance between scientific ambition and ethical stewardship. She knew that her work would be a vital part of the task force's efforts, contributing to Augustus Musa's grand vision for immortality. Dr. Sarah Monroe's journey from medical school to the forefront of cryobiology was driven by her relentless pursuit of life extension and preservation. As she continued to push the boundaries of cryonics, she remained committed to ensuring that her work adhered to the highest ethical standards. The frozen bodies in her care represented not just scientific challenges, but profound human hopes for a future where death might be overcome. And she was determined to honor those hopes with both scientific rigor and moral integrity.